All right, welcome back. Today we're going to go over the setup on some of the word problems here on this worksheet. This is the 6162 word problem day one worksheet. So I'm going to go through the setup and help you with a couple of these to get you rolling. So we're going to jump in right away with that first problem, the grocery problem here. We've got Phil and Mrs. Jackson who went to Century. And you can see that X is going to represent our pounds of hamburger and Y is going to represent our chips. And they tell us that Phil purchased 2 pounds of hamburger and 1 pound of chips for a total of $12.17. Mrs. Jackson, on the other hand, she bought 3 pounds of hamburger and 5 bags of chips for a total of $32.92. You have the option here. You could take Phil's equation and solve that for y and do substitution. I opted to multiply, so I'm going to multiply Phil's equation by 5, and you're going to see that right here. So I took Phil's equation, multiplied it by 5. Now I can subtract and get rid of those y terms. I didn't do the rest of the work for you. I got you started, but multiplied Phil's equation by 5. And now I can subtract those two equations to cancel out the y's. I'll get 13x equal to whatever this number is here. And then from that point, or excuse me, maybe negative 7x equal to this number. Solve for x. Once you have the value for x, then you can plug it back in to the top equation to in turn solve for y. So that's how we'll handle that first one. And now we're going to carry on to the next problem. All right, that second problem is the tickets for the Broadway musical. So you got a couple families going to see The Lion King. So we have adult tickets and kid tickets. So that's the first thing. We've got to define the two variables there. So the Smith family has 2 adults, 3 children's tickets for a total of $171. The Jones family has 3 adult tickets, 5 kids, and $270 total. And so you now have those two equations again. I don't recommend you solve for x or y here because you get fractions as far as if you're going to do substitution. So I would multiply. So it's your call here. You've now got the setup. Whether you want to eliminate the x's or eliminate the y's, you're going to have to do so by multiplication. But again, we defined our variables. We set up the equations for the two families. And now you are able to use elimination through multiplication to solve for x and y. So again, got you rolling on that one. The next problem is the job offer problem. Again, I'm going to help you with the setup here. So x is going to be the amount of our sales and y is going to be your paycheck. The first company offers a straight commission of 6%. So if you were to sell $100, you make $6. If you were to sell $1,000 worth of stuff, you'd make 60 at that point. If it was 10,000, you make 600, and so forth. So obviously, the more you sell, the more you make. The second company offers a $350 salary per week plus the 3% commission. And so you can see company 2 there is the payment for that one. And we want to know how much you have to make the straight commission job the better offer. So at what point will the straight commission be better than the weekly salary of $350 plus 3%? So we're going to set the first one. Since we have two things equal to y, they're equal to each other. So we can set 0.06x greater than the second offer, and we're going to solve this for x to see exactly how many dollars in sales we have to have each week to make job 1 a better deal than job 2. So again, we've got that set up for you so you can define your variables. We set up our two equations for each job offer. Because they're both equal to y, we can in turn set them equal, in this case, greater than first one. When is the first one greater than the second one? And we'll solve this for x. So you're going to subtract the 0.03x over and divide, and you will have your answer. break-even analysis, and then there's also a question about profits. So this is a two-parter. Again, I'm going to help you with the setup here, and you can go ahead and finish that out. And I'm going to stop here for a second because I got a typo to fix. All right, so we'll do our break-even analysis, not our break-even analysis. I don't know who Evan is, but we don't want to break him. So break-even is when your revenue equals cost. So for example, if we just use McDonald's here in town, if it costs them $1,000 a day to stay open, they have to sell $1,000 worth of food and drinks to break even. And anything they sold above that $1,000 mark would be their profit. So this particular fast food restaurant, they invested $5,000 in order to produce a new item, and they're going to sell it for $3.49 a piece, and it costs them $2.16 to make each item. So their revenue, that's how much they are charging or selling it for. That's the $3.49 here, and you can see that down at the bottom. So our revenue, $3.49 per item. Our cost is $2.16 per item plus. So again, revenue $3.49 per item. Our cost is $2.16 per item to produce it, plus the $5,000 investment that they had. So when we're looking for break even, we're going to set revenue equal to cost and solve for X. The second part of this deals with profit, and profit is equal to revenue minus cost. We want a profit of $8,500. So we're going to take our revenue here minus our cost, and again, we'll solve this equation for X. That'll tell you exactly how many items you need to sell in order to make $8,500. Part A will tell you how many items you need to sell in order to break even so that you can stay in business. Obviously, the goal is to make profit. You don't want to just break even, then that means you're paying your bills and you're not paying yourself. So once you make profit, that's the money that the business owner or company is making. I'm going to skip over this orange juice problem, the nutrition one. This is a mixture problem. It's going to be very similar to what I'm doing on the next example. So once we go through these mixture problems, that should help you with the orange juice one and also with the investment portfolio ones. So here we have 10 liters of a 30% acid solution is obtained by mixing a 20% solution with a 50% solution. So we've got one that's over 30%, one that's under 30%. We're going to mix them to get a 30% mix, and we know we have a total of 10 liters. So I just said X is the 20% solution, Y is the 50% solution. I know that the sum of those two is 10 liters. And if I solve this equation for Y, I can get Y equals 10 minus X. That's going to come into play with the second equation here. All told, I have a 30% mixture for 10 liters, which is made up of 20% of X liters and 50% of Y liters. This is why we had to solve that first equation for Y, because right now I got two variables. So the first thing I'm going to do, I'm going to replace Y with 10 minus X. Now I only have one variable in this equation. I'm going to distribute over here. You can see I have two X terms, so I'll combine those. And once I get to that point, I can solve for X. I can subtract 5 and in turn divide. So when I do that, I find out that X is 6.6 liters. Once I know what X is, I can plug it back in here, 10 minus X to find Y. And then I find out that Y is 3.3. So I have 6.6 liters of the 20%, 3.3 of the 50%. And when I mix those together, that will give me the 30% ratio. We kind of had an idea before we even started that we were going to need more of the 20%. And the reason we know that, if you just look at 20 and 50, the midpoint would be 35. So if I did 5 liters of each, we'd be right in the middle at 35%. Well, 30% is lower than that, so I know I need more of the 20% mixture in order to drop that percentage down. So again, we set it up here. We had our total liters was 10. We set up the mixture, so that was the percentage of each one. So 30% for the full 10 liters, 20% for X, 50% for Y. Using substitution, we're able to replace Y and in turn solve. So that'll help you now when you go back for the orange juice problem. When you get to these investment portfolio ones, so here I have two funds, 7.5%, 9%. So X plus Y will be 12,000. And then you have your 7.5% times X plus 9% of Y is going to equal your interest. That will be your second equation. So I'm going to pause this real quick and type it. It'll be a split-second pause in your video. It'll be a few minutes in real. All right, so again, what you see here is our total of the two accounts. That is X and Y, adds up to 12,000. I define X as the amount in the account drawing 7.5% interest, and Y is the amount in the other account, the one that's getting 9%. So the total investment between those two accounts is 12 grand. The first one is giving you 7.5%, so that's 0.075%, or 0.075 is a decimal, equals 7.5%. The second account's giving you 9% interest, and your total interest for the year is 990. So now we have our system. I would solve this top equation for either X or Y, and then plug it into this bottom equation. That will allow you to solve for the first variable. Then you can plug it back in here to get the second one. So that will help you with the two investment portfolio questions. I think we've got all the setups covered there, so you have the hour to work. Please make sure you get this done for Monday, and we'll take any questions you have then. All right, have a great weekend.